Hello viewers, in today's session we are going to discuss the solution of this logarithmic equation. So here we have to solve this equation where we have logarithm of x to the base 4 minus logarithm of 2 to the base x is equal to 7 over 6, right? So in order to find out the solution of this logarithmic equation, we are going to make use of some concepts, right? So the first one is to define the domain of this term, that is a logarithm of x to the base 4 and logarithm of 2 to the base x, and then we'll also make use of the base changing formula, and then we'll reduce this equation into a standard quadratic equation, right? So let us see how we can easily solve this equation, and we can easily get the solution of this equation. So now here we have logarithm of x to the base 4, right? So in order to define the domain of this term, we should have x greater than 0, right? And here in this term we have a log of 2 to the base x. So this x should be greater than 0, and moreover x should not be equal to 1. So first we have these two conditions, that is x should be positive, that is it should be greater than 0, and x should not be equal to 1, right? And then we can make use of the base changing formula, and the base changing formula goes like this. If we have a log of say b to the base a, and we can now use the formula like this. Here if we wish to change this base a to some base say c, then we can write here c, and then we have b, and here we have log of a to the base c, right? So this result is known as base changing formula. So now let us apply this result to this term. So this term, that is a logarithm of x to the base 4, can be written with the help of this result. So here the value of a is 4, the value of b is x, right? So let us change the base that is from 4 to x. So we can now write here log x to the base x, and here we have log of 4 to the base x, right? And here log x to the base x is 1, so we can now write log x to the base x is 1. So here we have 1, and here we have log 4 to the base x. So here we can now write this 4 as 2 square. Here we have x, and using the properties of logarithm, we can take this 2 in front of this logarithm. So we have 2 times log 2 to the base x. So here we have used this result, that is log of m raised to n is given by n times logarithm of m, right? So now we can replace log 4 to the base x by 2 times logarithm of 2 to the base x. So now replacing this term by this one, we can now write this equation as 1 over 2 times log of 2 to the base x, and then we have minus log of 2 to the base x is equal to 7 over 6. Now we can see that here we have a log of 2 to the base x. Here also we have a log of 2 to the base x. So let us assume that p is equal to log of 2 to the base x, and let us replace log 2 to the base x by p in this equation. So we have 1 over 2 times p, then we have here p, and this is equal to 7 over 6. So now we can simplify this expression. So we have 1 minus 2p square over 2p is equal to 7 over 6. So now we can here write taking the cross multiplication. So we have 6 times 1 minus 2p square is equal to 2p times 7. So we have 6, then we have 12 p square, here we have 14 p, right? So now we can rearrange the terms here. So we have simply 12p square plus 14p, and then we have minus 6 is equal to 0. And here we can see that we can divide both sides by 2. So here we have 6p square, because 2 is the common factor here. Then we have 7p, and then we have here 3, right? So we have obtained a quadratic equation here in p, where p is logarithm of 2 to the base x. Now we can easily solve this quadratic equation by either using the method of splitting the middle term or the quadratic formula, right? So here we'll make use of the method of splitting the middle term. So here we have 6 times minus 3 is minus 18. So we can split this term 7 like this. So we have here 6 p square, then we can write 9 p minus 2p, and here we have minus 3. So here we have 6 times minus 3 is minus 18, and minus 18 can be written as 9 times minus 2, and 9 plus minus 2 is equal to 7, right? So this is how we can make use of the method of splitting the middle terms. So now here we have 3p common, so we can now write here 2p. Then we have here 3, and here we have minus 1, and we have 2p plus 3 is equal to 0. So now we can write 2p plus 3, and here we have 3p minus 1 is equal to 0. So now we have two linear factors. So we have 2p plus 3 is equal to 0. Then we have 3p minus 1 is equal to 0. From here we have p is equal to minus 3 over 2, and from here we have p is equal to 1 over 3. So these are the two roots of this quadratic equation, and here this p is given by logarithm of 2 to the base x, and we need to find out the value of x. So now here we have assumed that p is equal to a logarithm of 2 to the base x, right? So this expression can also be written as x raised to p is equal to 2, right? So these two expressions are equivalent. So x raised to p is equal to 2. So now we can also write this expression as x is equal to 2 raised to 1 over p, right? So raising both sides as the power, that is 1 over p. So from here we can also write x raised to p, and raising both the sides to the exponent 1 over p. So here we have 2 raised to 1 over p. So here p and p get cancelled. So we have x is equal to 2 raised to 1 over p, right, which is same as this one. So now we can take first p is equal to minus 3 by 2. So taking p is equal to minus 3 over 2 in this expression. So we have x is equal to 2 raised to 1 over minus 3 over 2. That can be written as 2 raised to minus 2 over 3, right? So the first solution of this equation is given by x1, that is 2 raised to minus 2 over 3, which can also be written as 1 over 2 raised to 2 over 3. And obviously this value of x, it satisfies both these conditions, that is x is greater than 0, that is this term is clearly greater than 0 and it is not equal to 1. So now let us take p is equal to 1 over 3 in this expression. So the second value of x can be obtained like this: 2 raised to 1 over p. P is 1 over 3. So taking 3 to the numerator here, we have 2 raised to 3 over 1. That is simply 2 cube, right? That is equal to 8. So the second solution of this equation is given by x2 is equal to 8, and this value of x, it also satisfies these two conditions, that is x is greater than 0 and 8 is obviously greater than 0, and x is not equal to 1, that is clearly 8 is not equal to 1, right? So this is how we can solve these type of logarithmic equations. So now let us verify that these two values of x satisfy this equation, right? So here the first value is that is x is equal to 2 raised to minus 2 over 3, and here we'll take this value in the left hand side. So the left hand side is log x to the base 4, then we have log 2 to the base x, right? So here what we will do, will make use of this result, right? So let us write the value of log 2 to the base x as we can take this term to this side. So we have 2 times log of x, log 2 to the base x, and then we have here log x to the base 4 is equal to 1. So from here we can now write log 2 to the base x as 1 over 2 times taking 2 times log of x to the base 4 in the denominator of 1, right? So here we write log x to the base 4. So now we can replace this term, that is log 2 to the base x, by this expression. So we have log x to the base 4, and here we have 1 over 2 times log of x to the base 4. So here we have now the only term, that is log x to the base 4. Here also we have log x to the base 4. So it is easy to verify the solution. So now we can take x is equal to 2 raised to minus 2 over 3 in this expression. So we have log 4 and log 2 raised to minus 2 over 3 to the base 4. Then here also we have minus 1 over 2 log 2 raised to minus 2 over 3 to the base 4. So now let us separately calculate the value of log 2 raised to minus 2 over 3 to the base 4. So using this result, we can now write minus 2 over 3. Minus 2 over 3 can be taken in front of logarithm. So we have log 2 to the base 4. So now we have minus 2 over 3, and log 2 to the base 4 can be written with the help of the base changing formula. So here we can change the base 4 to base 2. So here we have 2, here we have 2, then we have here 2, and here we have 4 using this result. So now here the value of log 2 to the base 2 is equal to 1, and log 4 to the base 2 is log 2 square to the base 2, and again using this result we have 2 times log of 2 to the base 2 and log 2 to the base 2 is already equal to 1. So here we have 2 times 1, that is equal to 2, right? So here we can now write the value of this expression equal to minus 2 over 3. This is 1, and here we have 2, right? So here 2 and 2 get cancelled, so we have simply minus 1 over 3, right? So the value of logarithm of 2 raised to minus 2 over 3 to the base 4 is minus 1 over 3, and let us substitute this value in this expression. So we have here minus 1 over 3, then we have minus 1 over 2 times, and here we have minus 1 over 3. So we have minus 1 over 3, and this negative and this negative becomes positive. We have 1 over 2 over 3. This is minus 1 over 3 plus 3 over 2, right? So taking the reciprocal here, we have 3 over 2. So now we can simplify this term. So we have the LCM 6. Then we have minus 2 plus 3 times 3 is 9. So this is 9 minus 2 is 7. 7 over 6. And here we have the right hand side. So this value of x, that is 2 raised to minus 2 over 3, is a solution of this equation because the left hand side is equal to the right hand side. So now let us verify this value of x, that is the second solution, that is x2 is equal to 8. So now let us take x is equal to 8 in the left hand side. So we have the left hand side log x to the base 4 minus log 2 to the base x. So let us take x is equal to 8. So we have log 8 to the base 4 minus log 2 to the base 8, right? So now we can easily make use of the base changing formula over here and over here. So let us first make use of this base changing formula to this term. So here let us change the base from 4 to 2, right? So we have now log 8 to the base 2 divided by log of 4 to the base 2 using this result, right? And similarly using this result over here, let us change the base from 8 to 2. So here we have 2, then here we have 2, and then we have log of 8 to the base 2, right? So now here we can write log 2 cube. 8 can be written as 2 cube. Here we have 2, and then we have log 4 to the base 2. 4 can be written as 2 square. Here we have 2. Then we have log 2 to the base 2. Here we have log 2 cube to the base 2. So now here we have 3 log 2 to the base 2. Here we have 2 times log of 2 to the base 2. Then here we have log 2 to the base 2, and here we have 3 times log of 2 to the base 2. So now the value of log 2 to the base 2 is 1. So here we have log 2 to the base 2, log 2 to the base 2. These two get cancelled. Here also these two get cancelled. So we have simply 3 over 2 minus 1 over 3. So now we can take the LCM here. So we have 6 as the LCM, and here we have 9 minus 2, that is 7 over 6, which is equal to the right hand side. So this value of x, that is equal to 8, it also satisfies this equation.